Hi you guys, welcome back. We're gonna go ahead and get into a new math called hanger math. But before we get started, we're gonna go ahead and take a look at the difference between an expression and an equation. So if you look right here, an expression, honestly the only difference is that an expression does not have an equal sign and an equation has an equal sign separating two expressions. All right, you guys, so this is going to be our first hanger problem. And if you take a look, we have two sides of the hanger, okay? This represents squares. This side represents circles. We have the equation right here. It says 1 plus 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 1 equals z plus z. So what that means is whatever this equals on this side is the same as this side. They'll balance each other out, okay? So let's take a look at it. Based on this hanger equation, what is the value of the squares, okay? So we need to look right here at our equation first. It says 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6, plus 1 is 7, plus 1 is 8. And if we count the squares, we have 1, 2, 3, 4, 5, 6, 7, and 8. So we can go ahead and conclude that each square is equal to 1. If we know that this side is 8, this side also needs to equal 8. So we are going to look at z plus z equals 8. Z equals the same thing. The two squares equal the same thing. You can't say 1 plus 7, that equals 8. No, you need to figure out what do each of these, the same number, added together equal 8. So a way that you can do that is we have two z's. We can take 8 and divide that by 2, and we'll end up with 4. So we know that z equals 4. And if we do that, 4 plus 4, we get 8. So each square equals 8, each circle equals 4. All right, you guys, so take a look at these 4 equations right here. We need to figure out if these 4 equations fit into our hanger. So if you take a look at A, it says 8 equals z plus z. Well, we know that circles are also equal to z, and those represent 4. So if we plug in 4 for z, 4 plus 4 equals 8. That is absolutely correct. So this equation fits in our hanger. Let's take a look at B. We've got 8 equals z times z. So same thing. Circles or z equal 4. So if we plug 4 in for z, that's saying 4 times 4 equals 8. 4 times 4 equals 16. That does not equal 8. Therefore, this equation does not fit our hanger. For C, it says 8 equals 2 times z. Remember, when we have a number and a variable together like this, that's just telling us that we need to multiply. So again, circle or z equal 4. 2 times 4 equals 8. That absolutely fits in with our hanger. And now this last one, D. We've got 8 times 1 is 8. And look up here, we just did this, 2z. 2 times z also equals 8 because z equals 4. So 2 times 4 is 8. 8 equals 8. That absolutely also fits into our hanger. So these 3 equations match with this one as well. So these 4 equations can be used to represent this one hanger. All right, you guys, so for the next 3 problems, we're going to be answering 2 parts. We're going to be solving for, or finding an equation that matches all 3 of the problems. And then you're going to find the value of the variable. So each problem is going to have a variable inside of it, and we need to solve for that variable. Take a look at question 2. When we look at these hangers, we know that what is on the left side of the hanger is the same on the right side of the hanger. If the hanger looked like that, then we know that this side would probably be lighter than whatever's on this side, okay? That's not the case. It's not uneven. Because it's equal like this, we know that this side is the same as this side. So an equation that we can write for number 2 is 1.5 plus W, because that's on this side, right, equals whatever is on that side, 3.2. Okay? So this is our equation. 1.5 plus W equals 3.2. Well, now we need to solve for W. One way that we can do that is we can subtract by 1.5. Subtract 1.5 from this side, subtract 1.5 from this side, okay? I'm going to subtract it. 5 minus 12 is 7. 2 minus 1 is 1. W equals, whoa, that's an ugly W. W equals 1.7. And in order to check our answer, we can go ahead and go back and plug it into the problem. So we know that 1.5 plus W, which is 1.7, equals 3.2. Does that fit? 7 plus 5 is 12. Bring the 1 over, 3.2. Yes, it does. Okay? Let's go ahead and look at this one now. For number 3, we know that square, forgot to write that in, is 4.5. Okay? So square equals 4.5, and we have these 3 y's. One way we can write this equation is 4.5 equals y plus y plus y. Okay? Another way we can write this equation is 4.5 equals, how many y's do we have? 1, 2, 3. 3y. Okay? So now we need to solve. I want to solve and figure out what y equals. The way I do that is divide by 3. I'm going to divide by 3. I'm going to divide by 3. Okay? If we take this problem, 4.5, and we divide it by 3, y will equal 1.5. Okay? And now we can plug that in. Plug it into the equation. If we did 3y, that means we're going to do 3 times 1.5. If we do 1.5 times 3, so I'll actually bring it down here for you guys so we can do it a little bit easier. 3 times 5 is 15. Bring the 1 up. 3 times 1 is 3, plus 1 is 4. We need to bring that decimal over. Bring the decimal over. 4.5, okay? Or we can do 1.5 plus 1.5 plus 1.5. And if we add all those up, we will end up with 4.5. So we can write multiple equations, but it doesn't matter which way you write your equation as long as you come up with the answer for your variable. So you can have used this equation, 4.5 equals y plus y plus y, or you could have used the equation 4.5 equals 3y. Either equation fits for this hanger. And our answer ends up being y equals 1.5. All right, you guys, so this is problem number 4. Just like we've been doing, what is on this side has to be the same value for what is on this side. So we know the equation we can write is 1/2 equals a plus 1/8. Now don't be afraid when we're looking at these fractions. There's multiple ways that we can solve this. One way though, I know that we have a 2 right here, that's one denominator, and an 8 right here, that's a different denominator. So we need to figure out the common denominators. One way we can do this though is, I know you guys love to visually look at your math. So I'm gonna draw a tape diagram, okay? If you guys look right here, we have 1/2. This is 1/2 of a whole, right? And now I'm gonna separate this one into 8ths. Okay, so now I separated this into 8ths. I know that this one right here represents 1/8. But if you guys look, this is where the line matches up, correct? So we don't even have to worry about what's on that side. We need to worry about what's on this side. So this right here represents 1/8, okay? How many more 8ths do we need in order for it to equal 1/2? We've got 1, 2, and 3. So this section right here equals 3/8. So A equals 3/8. For those of you that aren't visual learners or don't want to go about it this way, you guys can always just take the equation 1/2 equals A plus 1/8. And when you do that, you need to subtract 1/2 from 1/8. So, or sorry, 1/8 from 1/2. So we're gonna go ahead and make this equation 1/2 with the common denominator of 8, because 8 goes into 1/2. So if you do that, we're gonna convert 1/2 to something with a denominator of 8. 2 goes into 8 4 times, and what you do to the bottom, you always have to do to the top. So 2 times 4 equals 8, 1 times 4 equals 4. So 4/8. 1/2 is the same as 4/8. It's an equivalent fraction. So now we can do this. 4/8 minus 1/8 equals 3/8. That works just the same. As always, you guys, make sure that you are taking your notes on this, and when you're done with your notes, download the independent work and make sure you work on that. Take a picture of your work and upload it onto our Google Classroom.